Hello again, everybody, and welcome to this class. Today, we will be discussing the electronic configurations, and we will be covering the 3 points: the ground state, representing the electronic configuration, and we'll be talking a little bit about the orbitals and the periodic table. As you studied before, the simple electronic configuration or structure of elements is represented by what you can see here in this figure, which means that we are representing the electrons in the levels of energy. For example, for lithium, which is containing 3 electrons, we will be representing 2 electrons in the first shell, then 1 electron in the second shell. And the electronic configuration is written as 2, 1. For neon, which is containing 10 electrons, we will be representing 2 electrons in the first shell and 8 electrons in the second one. In this case, the electronic configuration is written as 2, 8, and so on. Now, we will be seeing another way of the representation of the electronic configuration. But before, we will be giving a definition for the ground state, which is actually the most stable electronic configuration of an atom which has the lowest amount of energy. And the ground state can be achieved by filling the subshells the lowest energy first, which means that when we want to fill the subshells with electrons or the orbitals with electrons, we will be starting with the subshell which have the lowest energy, which means we will be starting with the 1s followed by 2s, 2p, 3s, 3p. Now in this place here, you can see that we have this overlap, which means that the energy of the 4s subshell is lower than that of the 3d. So in this case, we will be filling 4s first, then followed by 3d. So that's it. In this figure here, this is the electronic configuration of the element hydrogen, which is containing 1 electron. We will be filling the first subshell, which is 1s1. The first one here, this is the principal quantum number, which means the level of energy, 1. Then the s is the subshell, and it's filled 1 electron. So the electronic configuration will be 1s1. Helium, for example, has 2 electrons, so its electronic configuration will be written as 1s2, which means that we will be filling the first subshell, 1s, with 2 electrons. And for lithium, which is containing 3 electrons, its electronic configuration will be written as 1s2, 2s1, which means that we will be filling the first subshell with 2 electrons, followed by the 2s subshell. And once lithium has only 3 electrons, so the first one will be filled with 2 electrons, then the second one, which is 2s, will be filled only with 1 electron. So then the electronic configuration will be written as 1s2, 2s1 for lithium. Generally, a question about this type of detailed notation will be often be asked like, use the 1s2 notation to give the electronic configuration of this element, for example. This is a simple way on how to remember how to fill the energy levels or how to write the electronic configuration. For example, for the element manganese, which is containing 25 protons or let's say 25 electrons, its electronic configuration will be as follows. So we'll be start filling 1s2 followed by 2s2 because the s orbitals are filled with 2 electrons, or they can hold up a maximum of 2 electrons. So 1s2, 2s2. Now we pass to 2p. 2p, the p orbitals, they can hold up to 6 electrons. So it will be 2p6, then followed with 3s2. After that, we pass to 3p6, then followed by 4s2, then 3d5. Okay, to finish the electronic configuration. So the number of electrons here, if we do the sum of the number of electrons, we will find 25, which means 2 plus 2, 4, 6, which means 10, 12, 18, 20, and 25. This is actually the full electronic configuration of element manganese, which means in the full electronic configuration, we will be representing all the subshells. Okay, and there is also another way of how to show or how to write the electronic configuration, which is called the shortened electronic configuration. And in this shortened electronic configuration, we will be looking for the electronic configuration of the noble gas. For example, argon is containing 18 electrons, and we will be writing it as argon, then followed by the rest of the electronic configuration. Now, for chromium and copper, these are actually exceptions. Okay, so if we want to write the electronic configuration of chromium, for example, it's expected to be as so, as you can see here, which means argon followed by 3d4 4s2. But actually, this element, its electronic configuration is written like so: argon 3d5 4s1. In this case, we will be filling the 3d5 before 4s1. Why? Actually, this is due to the fact that those two subshells are so close in energy, and also to the fact that this electronic configuration is more stable than this one. Why? Because the d subshell or the d orbitals are half filled, because the d orbitals will be more stable if they are half filled or totally filled, as we will see in the copper example. So for copper, for example, now its expected electronic configuration is argon, which means 1s2, 2s2, 2p6, 3s2, 3p6, 3d9, 4s2. But we'll write it as so. We'll write it as 3d10, 4s1. Why? Because, as we said before, this configuration here is more stable than this one, due to the fact that these two subshells are so close in energy, and also to the fact that the d orbitals are more stable if they are half filled or totally filled, because we said before that the d orbitals are containing 10 electrons. So if they are half filled, they will be containing only 5, and if they are totally filled, they will be containing the whole 10 electrons. As you can see here, the periodic table actually can be represented in blocks, okay? The S block, the P block, and the D block. This means that depending on the electronic configuration of the element, we will find out its emplacement in the periodic table. So for the S block, actually the elements in S block, they have their valence electrons in the s orbitals. For example, let's say hydrogen, it's 1s1, so its electronic configuration, or let's say that the valence electrons are in the s orbital. For the p block, here the electrons or the valence electrons are found in the p orbital, and for the d block, which are generally the transition elements, their electronic configuration or the valence electrons are found in the d orbital. So thank you for watching, and see you in next video. Goodbye.